Here we're given two statements in orange, f of x equals x squared minus 9 over x minus 3, and that f of x is continuous at x equals 3. Now these statements seem to be at odds because if I take the number x equals 3 and plug it into this function, I get something kind of worrisome. When I plug in 3, I get 9 minus 9 over 3 minus 3, which is 0 over 0. And you're like, well, that seems to be an issue because after all, we were told the function was continuous at x equals 3. But that's okay. If it's continuous, even though we get 0 over 0, it must mean there's a hole on that graph at x equals 3. So I don't know what this graph looks like. I'm just going to kind of draw some random sketch. But at x equals 3, we should get some hole here because after all we have 0 over 0. But that hole is going to be filled in by whatever that we define f of 3 to be. After all, we're told it's continuous at x equals 3. So what is that value? What is that magical value that gets filled in? How can we figure that out? Well, what we're going to do is evaluate the limit as x approaches 3 of x squared minus 9 over x minus 3. We've already established this is 0 over 0, but hopefully you know by now that getting the form 0 over 0 means we got to do some sort of simplification. And in this case, that means factoring. So I'm going to factor the numerator into x minus 3 times x plus 3 over x minus 3. Now notice, because of these x minus 3's, they're going to cancel, and I can safely evaluate the limit as x approaches 3. When I plug 3 into this function now, I get 3 plus 3, which is 6, and this is the desired value for which this function is made continuous.